Okay, here are the first two parts of the Chapter 6 review. Um, Starting in Part A, we're going to solve these with reduced row echelon form. You have already taken a quiz with 2 by 2, with two variable, two equation problems, so I'm only going to put these calculator type problems on the test. So you do need to be familiar with the calculator and how to solve it. What I do want you to write, though, is the augmented matrix. I did put that in the directions. So the matrix we're going to start with to solve number 1, we simply write down the coefficients of the variables, 1, -2, 1, 2, 1, -3, and 3, -1, 2. And then we're going to augment that 3 by 3 matrix, which means we're just going to add onto it the numbers on the other sides of the equation. That's the matrix we'll start with. I'll store that in my calculator as matrix A, and then in my calculator I will do reduced row echelon form of that matrix A, and that would give me an answer, which I haven't punched in yet, so I'm going to have to look for that. But for now, before I pull out my calculator, I'm going to go ahead and start and write the first matrix we're going to use on all of these. So it'd be 1, 2, -1z, and it equals 2. Then I have 2x, 1y, -3z equals -1. 2x, 4y, -2z equals 8. And that's going to be the augmented matrix for number 2. And then for number 3, your matrix is going to be 3, 5, -8, -3, 2, 5, -2, and -7. Then I have -1x, -1y, 4z, and -1. And there's our matrix for number 3. So I'm going to punch these in the calculators. Now we'll get the reduced row echelon form. And when I punched that in the calculator, I got the matrix for number 1. I got the matrix 1, 0, 0. And all of these reduced row echelon forms are going to have, well, you should get the identity, but I do right there. And then on the right side, I have the numbers -1, 1, and 2. And the significance of this, you don't want to just stop by writing this. I want you to show me that you understand that this means that the value of x that satisfies this system of equations is -1, and that's what the top number tells you. The second one, y is equal to 1, and then here I have 1z equals 2. Or you could write that as an ordered triple, -1, 1, whoops, -1, 1, 2. So that will be our answer for number 1. And then we'll do the same thing for numbers 2 and 3. You punch those in the calculator. Remember, this is a 3 by 4 matrix, so when you're editing your matrix, you put in a 3 by 4, and then we do reduced row echelon form of that matrix. And this is what I want you to write. I want you to write all of this, the original matrix, your reduced row echelon form of the matrix, and then you need to tell me what the values of x, y, and z are. Show me that you can interpret this reduced row echelon form. So I'm going to pause this while I work out those other two, and when I unpause it, you will have the answers to numbers 2 and 3. There we go. We have, I did reduced row echelon form for both of these, and for both number 2 and 3, we got some interesting situations. On number 2, if you look at it, I didn't get the identity matrix, and at the bottom, I got all zeros and then 1. Well, what that's saying, if I were to take that bottom equation, that's saying 0x plus 0y plus 0z is equal to 1, and that's trying to tell you that 0 equals 1. That is not true. If you get a false statement at the bottom, that means there is no solution for this system of equations. So you need to understand what that means. And then for number 3, I got a similar situation, except my very bottom row is telling me that 0x plus 0y plus 0z equals 0, or it's telling me that 0 equals 0, which is a true statement. If you get a true statement, that means the answer is infinite. You could say infinitely many. I'm simply going to say there are infinite solutions. And we'll stop it with that. There is a little bit more we could do with an infinite solution case, but we're going to stop by just realizing that there are infinite solutions. For number 2, there is no solution. And then number 1, there actually was a distinct solution of -1, 1, and 2. So there we go. Part B, we are multiplying matrices. remember when you multiply, you first need to identify the dimensions, and these need to be done by hand. That's what those little stars by the numbers mean. This is a 2 by 2. This is a 2-row and 3-column matrix. If the middle two numbers match, then that means we can multiply, and my answer is going to be a 2 by 3 matrix. So I'm going to go ahead and draw my outline for a 2 by 3 matrix. That's 2 rows and 3 columns. So 2 rows, I like to give myself lots of room. And I'm going to go ahead and write blanks. It's 2 rows and 3 columns. So I'm going to fill in these blanks. And then this is when we start by multiplying the rows of the first matrix times the columns of the second matrix. So when I do first row times first column, that's 1 times 2 plus 0 times 0. And then I will do first row times second column. 1 times 0 plus 0 times 4. And then I'll do first row, third column. 1 times -3 plus 0 times 5. And then I'll move down and do my second row, and I'll start back at the first column. So -3 times 2 plus 4 times 0. And then down the second column, -3 times 0 plus 4 times -4, which is -16. And then finally, second row, third column, -3 times -3 is 9, plus 4 times 5 is 20. And then we will finally add those together. 2 plus 0, 0 plus 0, -3 plus 0, -6 plus 0. I love the zeros. 0 minus 16, and 9 plus 20. Boy, that one was tough. No zeros in that. So here's our answer when we multiply those matrices for number 4. Number 5 going to be the same thing. This is a 1-row, 3-column. So we have a 1 by 3, and then we're multiplying it by a 3-row and 2-column. Middle two numbers match. That means we can multiply. And my answer is going to be a 1 by 2 matrix, pretty small matrix. So I need 1 row and 2 columns. So my answer is just going to be real nice and clean. 1 row, 2 columns. And we'll start multiplying. This row times the first column, 2 times -1, 0 times 2, plus 5 times -7, which is -35. And then I'll go down the second column, multiplying each element, 2 times 1, plus 0 times 4, plus 5 times 9. And then we'll add those numbers together. -2 minus 35 is -37. 2 plus 0 plus 45 is 47. And there's our answer for number 5. Number 6, multiplying again. This is a 2 by 2. And this is a 1, 2, 3 row and 2 column. These numbers do not match. Therefore, you cannot multiply. And that's all we have to say for this one. You cannot multiply these matrices. I love those problems. Yay, that's worthy of a triangle man. Yeah, dog. There it is. Woohoo!